Good morning. All right, this is a tutorial on Mountain Math question number 12. To get to our Mountain Math set, kids, your Google Classroom, Mr. Tillish's 4th grade class is all set for you. If you click on classwork, it will bring up your topics. Okay, so you have a topic called My To-Do List, a Zoom topic for our Zoom meetings, an Avid topic to access your SMART goal information. Over here on the left-hand side, it is a menu of all your topics. Today, because we're doing Mountain Math, we're going to go to Virtual Learning Math or Distance Learning Math. We are going to, once we click on that, we'll see that we're in the area of Mountain Math. Also in this virtual learning, you got your fraction strip tools, you have your IXL tutorial and your charts, and you also have a digital copy of all of your lessons in case you have lost them, misplaced them, whatever. So we're going to scroll back down to Mountain Math, and we're going to, for these purposes, click on Mountain Math 23. That's just the set number. And we are going to focus over here on number 12. Okay, so number 12 is an absolute doozy. And the space that they give you on your Mountain Math page is certainly not going to be enough for you, or enough room for you to be able to complete the problem successfully without frustration. And so I'm going to ask that you get yourself out a piece of your scratch paper and you use that. Okay. So our numbers that we're working with today in number 12, I will switch back over to the Mountain Math screen. The problems that we will be dealing with are, or the numbers we will be dealing with are mixed numbers. They're mixed numbers because it has a combination of a whole number, 9 and 10, and a fraction, okay? So a part of a whole number. So when you take a whole number and a fraction, you put them together, what you've done is created a mixed number. It's mixed up. And so we have 9 and 2/8 is how you say that. And then the second number that you have is 10 and 4/6. Okay? So what I will do, as soon as I've written these numbers down into the appropriate section for Mountain Math, I am going to move over to a piece of scratch paper. Okay? But first, let's read the questions. What is actually being asked of us here when comparing fractions, or in this case, mixed numbers? And it asks immediately, are the fractions equivalent? Well, that's just like asking, are 9 and 10 the same? Are they equal? And if you can answer that question, you've probably already said, Mr. Tillish, you're crazy. 9 and 10 are not equal. Okay, 10 in fact is bigger. Well, because 10's bigger, that makes 9 and 2/8 automatically less than 10 and 4/6. So in a lot of ways, when you're comparing mixed numbers and these whole numbers are different, it's going to make your life really easy to answer that question, yes or no. Are the fractions equivalent? And no, they are not equal. 10 is larger than 9, so therefore 9 and 2/8 is less than 10 and 4/6. Now that's really no biggie up to this point. You've looked at a couple of whole numbers and you determined that these mixed numbers are not equivalent. It's this next piece, okay? It says if not, okay? If they are not equivalent or they're not equal, you've got to make them equivalent. And that is where you want to grab your scratch paper, okay? Now, when you grab this scratch paper, it's going to give you plenty of room, okay? So basically, the question we're trying to answer, or the command that was given to us, is make them equal, okay? And when we go to make them equal, well, to remind ourselves, we have 9 and 2/8, right? And 10 and 4/6. So the first thing we want to ask ourselves is, well, let's deal with the whole numbers. In order to make these mixed numbers equal, these whole numbers have got to be the same. So you got two options, okay? You can think about, how do you make 9 from 10? Well, 10 minus 1 is 9. Or how do you make 10 from 9? And 9 plus 1 would be 10. So in that case, you got two options. You can subtract, right? Or you can add. And when you go to subtract, you're subtracting something from 10 to make it 9. So in this case, you can say 10 minus 1 equals 9. Okay? Or you could add and say 9 plus 1 equals 10. But just choose one, okay? Do you want both whole numbers to be 9, or do you want both whole numbers to be 10? Okay, let's just go ahead and make both whole numbers 9. Let's assume that we are going to keep 9, or now you have 9 and 2/8. And when we took our subtraction problem, how do we make 9 from 10? 10 minus 1. Now we have 9 and 4/6. Okay? So we're just playing around with the operations of mathematics here, in this case addition and subtraction. Now we have to, once we've made our whole numbers the same, okay? Now we got to come down and make 2/8 and 4/6 the same, okay? Now, if we're gonna make 2/8 and 4/6 the same, right, we are gonna have to dive into a new topic that we will go over more. And if you're watching this video during spring break, it's gonna be next week that we'll start talking about the idea of least common multiple, okay? Now, if that sounds familiar, it sounds familiar because that is question number 5 when it comes to mountain math, okay? Putting a star around the least common multiple. So you've already started to dive into that skill of locating the least common multiple in order to make 2/8, okay, and 4/6 equal. These are the two fraction bits of our mixed numbers, okay? So to make 2/8 and 4/6 equal, what we have to do is locate the least common multiple of the two denominators, right? And so we are going to write down 2/8, right? Then we can write down, zoom out here, and then we can write down 4/6. And because we're finding the least common multiple of our two denominators, right, we're gonna make some space here because eventually we're gonna have a new denominator for both these fractions. And believe it or not, they're actually going to be the same denominators, and that's going to help us make the fractions equal, okay? So what we can do is we can look at the multiples of 8, okay? So as we are listing the multiples 8, I'm just gonna draw these boxes here for future reference. Okay, and now we can start listing the multiples. We have 8, 16, 24, 32, 40, 48, and let's just go 56. Okay, now we can list the multiples of 6. We have 6, 12, 18, 24, and I've just found the least common multiple, the smallest multiple that 6 and 8 have in common, and that's going to be 24. As I'm listing the multiples of 6, I'm looking up here at the multiples of 8 to see if, to recognize the moment that the first multiple that they have in common. And in this case, it was 24. So what does that mean for us? Well, it means that our new denominator for 6 and 8 is going to be 24. Why? Because when your denominators are the same, it's way easier to figure out how to make two fractions equivalent or equal. Okay, so if the denominators are the same, then all we have to do is make the numerator or our top number in our fraction the same as well, which will kind of go back to the skill that we use to make our whole numbers the same. So once you find the least common multiple and you enter it in as your new denominator, you're not quite done with that whole least common multiple step yet. Because you have to ask yourself, what did you do to 8 to make 24? Well, we multiplied it by 3, okay? What did you do to 6 to make 24? We multiplied it times 4. The big kicker here is whatever you do to any number in your fraction, whatever we're doing to 8, we have to do the same exact thing to 2. And the same goes for that 6 and the 4. Whatever you do to 6, you gotta do the same thing to the 4. Otherwise, it throws your fractions off, and all of a sudden, you're dealing with different amounts, different size pieces of the whole, and different amounts of those size pieces of the whole. And so if I'm multiplying 8 times 3, I'm going to do the same thing to 2, and I'll get 6. If I'm multiplying 6 times 4, I'm going to do the same thing to 4, and I'm going to multiply it times 4. So now I'm creating a new numerator. And now we have two new fractions. We have 6 24ths and 16 24ths. Okay, now we ask ourselves, if these are our two new fractions and we want to make them the same, remember our whole numbers are still the same, we have to ask ourselves, do we want to make 6 turn into 16, or do we want to make 16 turn into 6? Since we subtracted at the top here to make our whole numbers the same, why don't we add to make 6 turn into 16. So what do we do to 6 to make it 16? We've got to take 6 24ths and we have to add 10. Now when we add 10 to 16 24ths, okay, or 10 24ths, I should say, we will end up with 16 24ths. Okay, so now we have just made our fractions 2/8, right, from 9 and 2/8, to be the same as 4/6. In this case, both are now 16 24ths. What are our new fractions now that we are comparing, are our new mixed numbers? New mixed numbers. Okay, remember we have two 9s, so we have 9 and 16 24ths. And we have 9, and not 4/6 anymore, 16 24ths. So we have tackled the task of making 9 and 2/8 and 10 and 4/6 equivalent. Now, I hope you've noticed that there is more than one way with the addition and subtraction here, and then the addition and subtraction that goes along with making your fractions the same. We could have taken away 10 from 16, but in this case, we added 10 to 16. And so there is more than one way to make your fractions equivalent. Now, the last bit, okay, is to make sure, and it doesn't tell you to do this in your directions, okay? I get it. It does not tell you in number 4 to put your two new fractions, okay, 9 and 16 24ths and 9 and 16 24ths. It doesn't tell you to put those in simplest form, but a big rule of thumb when you are making fractions equivalent, or you're ordering fractions, whatever operation you're doing with fractions, you want to make sure to put your final answer into simplest form. Okay, so I'm going to write up at the top of this box here, simplest form. Okay. And in order to put a fraction into simplest form, you're going to go back to number 4. Number 4 is the GCF, the greatest common factor. Okay? And we are going to be listing the factors of both 16 and 24, as that is our new fraction that we are working with. Okay? And you can look at it in number 4 as 16 24ths, right? You got your first number and your second number, or your numerator and denominator, or your top number and your bottom number, and you can start listing the factors of both of them, or listing the factor pairs. So I am going to also just remind you that when we found the least common multiple, we found the least common multiple, not of 2 8s and 4 6, but just the denominator, just the 8 and the 6. Okay, so we could also plug that into number 5. Okay, and as you're doing that, you're doing all of this here that we just did, but you can essentially look at it as, when I'm finding the least common multiple of my two denominators, I am just doing number 5 again. Thank you, Mr. Tillers, for making me repeat number 4 and 5, because number 4 comes in handy with simplest form. We have 16 24ths. Okay? Factor pairs. What are your factor pairs of 16? You have, obviously, 1 and 16. It's an even number, so 2 times 8. And then we have 4 times 4. So when we go to list those factors now of 16, we have 1, scratch it out. We have 2, scratch it out, used it. We've got 4. Yes, there are 2 4s, but you only need to list 4 once. Okay? Then we have 8. And we have, scratch it out, 16. And you've just listed your factors for 16. Okay, now we are going to list the factor pairs of 24. Okay, so it's starting to look, right, instead of factor pairs of the first number, factor pairs of the second number, kind of the way number 4 looks, factor pairs of 24. Okay, by listing the factor pairs, you're going to limit your silly errors. When you list the factor pairs, it makes it harder to forget a factor when you are listing them out. So factor pairs 24, we have 1 times 24. It's an even number, so we have 2 times what? 12. We also have 3 times 8. This is where your multiplication tables certainly come in handy. Then we have 4 times 6. And we have 5, 6, 7, 8, 9, 10, 11, 12 times 2. All right, I think we have listed the factor pairs of 24. So now let's write them down. We got 1, scratch it out. 2, scratch it out. 3, scratch it out. 4, 6, 8, 12, and we have 24. Okay, so now what do we do? Well, number 4 says greatest common factor. Greatest means biggest. What is the factor that both 16 and 24 have that are the biggest? We have 1, good, both got it. 2, both got it. 4, they both got it. 8, they both got it. 16 and 12, 24. It looks like 8 is our greatest common factor. When we go to use the greatest common factor 8, then we just ask ourselves, what are we going to do with that 8? Well, we want to put the fraction in simplest form, so we want our top number and our bottom number, our numerator and denominator, to be as small as possible. And in order to make it small as possible, you've got to use the biggest number, the biggest factor, the greatest common factor to divide by 16 and divide it by 24. So 16 divided by 8 and 24 divided by 8. Okay, 16 divided by 8 is 2, and 24 divided by 8 is 3. We have just taken 16/24, put it into simplest form, and we got 2/3. In all of this, our whole number has not changed. Okay, our whole number is still 9. And they are equal at this point, and you could stop at 9 and 16/24. But kids, once we enter into that 5th grade realm next year, we want to be able to put our fractions into simplest form. It's kind of putting the cherry on top of everything else that we just did with our fractions, okay, or our mixed numbers. So now we have 9 and 2/3 is equal to another 9 and 2/3. So we have just answered likely the most difficult part of number 12. Okay, we have made them equivalent. And how did we do that? We went through a whole bunch of steps. Least common multiple, and made our whole numbers the same, got our denominators the same, and then we finally put it into simplest form. 9 and 2/3 is now equal to our other 9 and 2/3. Because if we assume that 16/24 here in simplest form is 2/3, so is that 16/24. Nothing different. I'm terribly sorry about this shadow line here that exists. Just one of those silly little problems that Mr. Tillish is not dealing with very well. Draw a picture of your fractions. All right, draw a picture of the two original fractions or mixed numbers, right? How do you do that? Well, the easiest way to do this is understanding this, that when you are dealing with 9 and 2/8, so that 9, to make those whole numbers, that is all broken in 8s. This is 8/8 9 times, okay? So that means that if you're looking at your fraction strip tool, these 8/8 here, right here, that is all colored in 9 times to make 9 wholes. And then to create your 2/8s, you would highlight 2 more 8s. And so drawing rectangles is going to be very helpful in drawing a picture of your fractions. I'm not going to show you an example of that, but I do want you to play around with the idea of drawing a picture of your fractions, and rectangles make it a lot easier. Making rectangles is going to ensure that you can create something very similar to this, and you can keep your wholes the same, right? So 3/3 and 4/4, right, is still, they're both equal to 1 whole. They are the same exact size. And so drawing a picture of them, you just need to make sure that all of your wholes are the exact same size. Okay, good. Now the last portion of this is add them. Add them. Well, when you go to add your fractions, you don't want to add fractions that are having different denominators right now, okay? So we are gonna add the fractions that are exactly the same, okay? So 9 and 2/3 plus another 9 and 2/3. We will add our whole numbers first. 9 plus 9 is 18, okay? Cross those 9s out, you're done with them. And then your 2/3. Anytime you're adding fractions, the denominator stays the same because you're still thirds. You're not changing the size of the parts or the whole. You are keeping them the same. We're dealing with thirds. And then you say 2 plus 2 is 4. You have 18 and 4/3, okay? So if you have 18 and 4/3, Okay, if you have 4/3, okay, you have more than one whole. Here we have 3/3. As soon as you have your 3/3 and you know you got more than one whole, and we know that because our top number is bigger than our bottom number, all right, 4/3. You know you got at least one whole. So 18 and 4/3 is actually equal to, well, if we have a 3/3 tucked in here, we got an extra whole tucked into 4/3 because we have that 3/3 in there and another third that makes our 4/3, right? So we could essentially give this 3/3 over here to our whole number 18. And now that 18 becomes a 19. We dealt with that 3/3. And what do we have left over? 1/3. So in converting an improper fraction to a mixed number, we have just created a new fraction once we've added them. And that's because we included our one whole that we got from 4/3 into our 18 and made it 19. And then we just wrote down our leftovers, which was our 1/3. Your final answer after adding them is 19 and 1/3. Okay? And then it says subtract them if you can. Now, when it comes to subtracting fractions that are equivalent, if you take away 9 2/3 minus 9 2/3, you have 0, right? But say we wanted to go in and subtract 9 2/8 minus 10 4/6, it says subtract them if you can. And if we could, this 9 would have to be larger than the 10, and so we actually get away a little easy on this one. We don't have to subtract it because you cannot subtract 9 minus 10 4/6, or 9 2/8 minus 10 4/6. We are done with number 12. I'm going to ask you to go in and draw that picture of your mixed numbers. As a review, here is the full work page that I've created. All of that is for number 12. A lot of problem solving, a lot of neurons firing in your brain, and maybe some frustration tucked in there too, for you kids and probably your family, some of your family that's sitting down trying to help and trying to remember how to do all of this. Good luck with number 12. You'll notice that when your next work pickup is next week, you will be picking up some more mountain math problems, and we'll go down to one mountain math form per week. I believe we've done more than that. So just remember, one mountain math per week, and you get a whole day just to work on number 12. All right? Happy equivalency as you continue cruising through our new lifestyle, boys and girls. Sure miss you. Glad to talk to you. Have a good one. Bye.